In another video, I showed you how I install those tiny little magnets, and one of my viewers had a really good comment. He asked me if I used any glue on those to hold the magnets in place. Now, in that particular case, I don't. The whole little 3D printed holes are tapered very slightly, and it's just a tight fit to begin with. So that's why I have to hammer them in. They have not come out so far, knock on wood. But there are instances where I need better entrapment or I don't want to use glue. Now, here's why I don't want to use glue in some points. Well, I do a lot of prototyping and I don't want to throw away magnets as I'm prototyping. I like reusing stuff where I can. And so I've come up with a technique, and this technique is kind of taken from some of the entrapped nuts that you see in some 3D designs, where you see the nut is actually gets slipped in as in between parts of the assembly. I saw that first in some of the Prusa printers, and it really got me thinking. And I use that extensively in this particular project. This is for a pitch bend wheel. So this is a wheel that musicians use to adjust the pitch. It has a potentiometer on the one side that's not here, and it has a spring that centers it, but I found that I really needed to lock in the center point, so I was going to use magnets to do that. And so as I modeled it, you could see what my clever plan was. What I did is I have a space in here to put my magnets. Now the magnets, the poles are coming out the end, and there's a very little bit of plastic here, so it doesn't drop too much of the magnetic strength. But it entraps them. And the other thing you do, I see I've put this cunning little hole in here so that when the magnets are placed in there, if I want to pop them out, I just use something like a push pin and pop it out, and I could reuse my magnets. So that's real handy. Because the magnets are being put in on their side like this, instead of futzing and having everything fall apart, this is another example of me making little tiny tools on the 3D printer. This is just a little piece of plastic, and on the one end it's concave, the same radii that, or whatever it is, that the magnet has. So in this case, and these are stacked, so I'm stacking two instead of using one big one, and I just kind of put it there and use the tool to push it down. And it took me a lot of time to get the distancing and the spacing right, but it holds in there fine, and they don't come out, and the primary attraction is on that pole, so they aren't going to get pulled out this way. You'll also notice that I use two magnets here. Why did I do that? Well, for some of my stuff, especially for folks with disabilities, I need to have different strengths, different tensions on things. Magnets are a good way to do that, and to have centering and return to center and whatnot. And by varying the number of magnets, you can kind of mess around with how strong they are. So if you need something really strong, you could have a couple of magnets. In this case, I found that two magnets for this process works really great. And then when I do the other end, I just take this, and see, it's like that, so I'm going to want them to mate like that. So I just hold that, and then I will, and I don't have my brass hammer with me now, of course, but I would just tap it in, and this hole here is just enough to hold two magnets. So it holds two magnets and none more, and they hold in place kind of like you can see there. And again, on the bottom side of this one, I have a hole so that if I want to get that magnet out, I just pop it, and there. Now I could, if this part was no good, I could throw it out. I still have my magnet. Even though they're inexpensive, it's no point in throwing away something good, right? Other thing not related to magnets on this is a subassembly. And you'll see a lot of my stuff, especially the complicated stuff, has more subassemblies. So if I'm making pitch wheels, I can make a bunch of these parts and cut all the springs and do all the pressing bearings into here and all that other fun stuff, getting the magnets. And I know that I've got a good mechanism, and I can sit it on a shelf so that when I do final assembly of my devices, I grab it. Okay, I need a pitch bend, I need a modulation, I need a this or that. And the other nice thing is repairability, right? Because if originally my design, this whole part was part of an overall base, and I broke that up. I actually have one in the printer I can bring over. So this was originally all one unit, but then, what happens is it breaks, and assembly was a mess. So by doing this, it allows me to assemble it a lot easier. I have these thick pads at the bottom, and that goes in like that. And then I use two M2.5 5 millimeter long fasteners, screws, to go in, and it holds it real nice. So one is on this side, and then the modulation is on the other, and it bolts right in. So if the modulation got cracked off or this one breaks, I could swap out that part of the assembly a little bit easier. It doesn't solve all problems, but I found that it really makes assembly easier. So that kind of veered off of the magnet thing, but gives you an idea of how I approach these sorts of problems. Thanks for watching.